Okay, so we're going to start our first unit, and our first unit is on functions. And so when we're talking about functions, I guess the first question is, what is a function? So we're going to try to answer that question. And what a function is a function for every input, you only have one output. That is the definition of function. So everything, when you put in one thing, only one thing comes out. Another way of saying this is, for every one x value, I have one y value. So an example of this would be this set of pairs would be a function because I have 1, 3, 2, 3, and 3, 3. Because for every 1x, I have 1y. They can be the same y's, that doesn't matter, but for every 1x, I have one y value. So this is a function. Hooray. This would not be a function, so not a function. We'll show you what that example looks like. That might be like 2, 5, 2, 7, and 1, 4. And so you'll notice on this one that this is not a function because I have a 2 here, and it goes to 5, and I have a 2 here, and it goes to 7. And that is not good. So that means like if you're thinking about it, 2 goes to both 5 and 7. And it kind of breaks the pattern idea because if I plug one thing in, how would I get two different answers? That's what a function is and what it does. So let's look at kind of what it would look like for this on a graph. So let's say I have this grid here, and we're going to have a graph that looks like, let's have a graph that looks like this, and ask if this is a function or not. And so if this is a function, that means for every x we have one y. Well, let's check that out because these are my x. That's one y. That's one y. There's one y. So as I go to every single point or every single x value, it would be a function if I only have one y value. So this thing is a function because at no point does one x ever hit more than one y. So when we look down, this only hits 1. We sometimes call this the vertical line test. And if you only hit one point, the thing will be a function. Let's see something that isn't a function. So here we go. Let me draw something that might not be a function. And we'll notice this thing will not be a function because if I go from here to here, I hit 1 point, but if I keep going, I'd hit 2. So this is bad because 1x has 2 different y values. So this would not be a function. Because for 1x, you hit 2 y values. So the x's, in this case, are repeating. So things that are not functions are things that fail this vertical line test or things that repeat x's. And that is the only way that you can fail to be a function. Let's talk about this idea of domain and range now. So the main idea behind domain and range is domain is your x values and range is your y values, or domain is your inputs and range is your outputs. And really the reason we look at this is to kind of see, do we have more x values than y values? Because if we have more x values than y values, sometimes that means that we would have repetition and this thing might not be a function. So we're really going to look for just how big these domain and range sets are. And the easiest way to look at them is on graph. But let's start with an example of this. So maybe you have the points 1, 3, 2, 3, and 2, and 7, 4. So we know this thing is a function because we don't have any repeating x values. The y's can repeat and that's fine. your domain in this case would be 1, 2, and 7. Your range in this case would be 3 and 4. And that's how you show a list, is you just make these parentheticals with, or brackets with the little lines outside. I think they're called indexes, but I'm not entirely sure. So this is normally how you just list out the points. Let's look at some graphs, though, where we can't just list out the points. Okay, so we're going to find the domain and range for this thing. You'd think that it'd be really easy to just write down all the x values, but that's actually not true, because there's a lot of x values here. Like there's an x value here and here and here and here. So there's a ton of just x values, so it's really difficult to list all of them. And with big lists, it's just not easy to do. So we're going to write our domain down. And your domain is your x values. So when we look at our x values, we're only going to look at like this axis here. And so I'm going to look where I start and where I end. So that's the big thing here, is you just look in the domain to see where it starts and where it ends, and that's all we're going to list. So this thing, the smallest x value, if we go along this thing, would be right here, which that goes down 1, 2, 3, 4, 5, 6. And the largest x value is out here. So 1, 2, 3, 4, 5, 6. And now after we've wrote that, how we showed that we're going from 6 to 6 is we're either going to use brackets or parentheses. If you can see the point, or this is a closed dot, we're going to use a bracket. So right here we definitely have a closed dot, so we're going to use a bracket. If it's open, we're going to use a parenthesis. But both these dots here are closed, so that would be our answer for our domain. Let's look at our range now. So range is your y values, and we're going to do the exact same thing. We're going to look for the smallest y values. So when I'm looking along the y values, the first point that we hit would be this one right here, and that's at the value 0. And again, I'm going to make this a closed bracket because it's a closed point. Then we're going to look for the tallest point. And the tallest point would be up here at 1, 2, 3, 4, 5, 6. We're just going to close that right there. And that would be my range's answer. Okay, so that's how we do domain and range. At the end of this, we'd say, is this a function? And yes, this is a function because it has only one point associated with all of these values. Let's do another one. So when we're looking at this one right here, again, we're going to do our domain. And so when I look at my domain, I'm going to look for my smallest point. And so when I go along here, the first x value I reach is at 0. And we're going to make that a closed bracket because it's a closed point. Then I'm going to keep going. So 1, 2, 3, 4, 5. So it looks like it happens at 5. And this time, I'm going to use a parenthesis because that point that it hits is open. Now we're going to do the same thing with our range. So our range, I'm going to look, and my smallest range value happens here at 0. So again, that's going to be a closed bracket. And then we're going to look for our highest point, which will happen at 1, 2, 3, 4, 5, 6, 7. And that's going to be an open bracket because that is that point is open. So again, it's really, I think, really easy for domain and range because you just look for your smallest point and then look for your biggest point. Let's do one more example of this. Okay, let's do the same thing. So my domain, when I look, it starts here, and that's going to be a closed point because we can actually see the point. So that's going to be a closed bracket, and that happens at 0 again. And then this is a little bit weird because as we go, we could say, oh, it stops here, but that's not true. These have arrows. So these things keep going, so it never stops. And since it never stops, we can't see what point that is out here because whenever you think you have the point, it's actually the next point. And whenever you get to that next point, it's the next point and the next point. So this thing goes off to infinity, which isn't a number, so we're going to use a open bracket. Anytime you use infinity, you're going to use this open bracket. And now we're going to look for our range. So we're going to go to our smallest point. And again, when you look at your smallest point, you might think it happens here at 1, 2, 3. But that's not true because this thing has an arrow. So this thing keeps going off. Since this is in the negatives of the graph, we're going to say that's negative infinity. So whenever it's in the negatives and it keeps going off, that's negative infinity. So we can distinguish between the two. And then here, we can see for the second one, for my biggest point, we could go, oh, it goes up to 1, 2, 3, but that's not true because it has an arrow, so that means it's going off to positive infinity. And this thing, if we look, would not be a function because it fails our vertical line test, so that's not a function. Okay. Let's do one example where we have to use the graphing calculator. So in this one, we're going to use the graphing calculator and we're going to try to find its domain and range. So this time we don't get the nice picture, but we're going to have to find the nice picture, which shouldn't be too bad. So we're going to go to this right here. We're going to go to y equals, and we're going to plug this in. Now you might go, where in the world are those absolute value signs? And they're under the math function. So we go down here to math, and we hit math. And then we're going to keep going down. Oh, my bad. So you go to math, and then you go over 1 to numbers, and it's that first number. See the ABS? That stands for absolute value. So now we can type in that x minus 2, and then go plus 3, and see what this graph looks like. So we get to see that graph, and obviously these things are going off to infinity. So again, we're going to find our lowest x value, which, because we don't get to see our lowest x value because it keeps going on, that would be negative infinity. And we always make that a parenthesis because we don't know what value that is. Same thing for my biggest x value when I go along this line. That's going to go to positive infinity. And we're going to use a bracket or a parenthesis because we don't know where that is. We're then going to look at our range. So this thing looks like its smallest value is right here at 3. So we're going to go for our range, we're going to go, well, that starts at 3. And that's a bracket because I can actually see that point. And then we're going to look and we're going to see how far up it goes. And because it keeps going up forever, that would be infinity. That's how we're going to do all the examples today. So if they don't give us a graph, we will graph it on our graphing calculator and see what that looks like. But if they give us a graph, that's what we'll kind of use to do it. If you have any questions on this, please let me know. And that's the problems.